Section 11.2 is on page 672. Calculus with parametric equations. Now that we know that x is a function of time, y is a function of time, if I take y equal f of x, and x is some g of t, and y is some h of t. So h of t equals f of g prime of x. If I take a derivative, that will be by the chain rule, derivative of f times g of t times the derivative, that will be the derivative f prime of g of t times g prime of t. And if you divide both sides by this, you will get f prime of g of t, and remember g of t is actually x, so the derivative of x is h prime of t divided by g prime of t. Another way of looking at this, another way of really looking at this, just don't want to clutter it, I add too many things. Another way of doing this is by say, well, let's see, y equal f of x. So if I take dy dx by the chain rule, I could say y depends on t and t depends on x. I could just make that connection. And in this case, I could say, well, that's dy dt multiplied, that's dy dt divided by dx. Oh man, I can get it right. Divided by dt dx, and instead of dividing, can't I multiply by the reciprocal? Okay, I'll get it right eventually. That was dy dt. And can't I say that is dy dt divided by dx dt? Wouldn't that be much quicker? So basically, this is how it works. If I want to find dy dx, y depend on t, take dy dt, and x depend on t, take dy dx dt. And the second derivative is a bit messy, and that's why we're just gonna cut it from the book. As for the second derivative, well, provided here, of course, I forgot to mention dx dt does not equal 0. Here, if I want to take the second derivative, I'm going to take the derivative of y prime, in which y prime is dy dx over dx dt. So I'm going to take the derivative with respect to t of my original y divided by dx dt. I could derive that, but that turns out to be too long and for no reason, and I'll mention that when we get there. This is provided on the formula sheet. If you look at the formula sheet that you have, I already listed that for you, so you could always use that. And let's play with some problems. We'd like to start with problem number 2 on page 680. It says, find an equation for the line tangent to the curve at the given defined point. Well, at the given defined point, at t equal -1/6, I know that x is going to be the sine of -2 pi over 6 and cosine of -2 pi over 6, and this will make it pi over 3, and that's going to be negative the square root of radical 3 over 2, and this will be 1/2. We just covered that in the previous section, section 11.3. So I know my equation for the line is y minus y1 equal m into x minus x1. So there, if I could figure out what the slope of the tangent is and plug that in, I'm done. How do I find the slope of the tangent? I think the best way, if you want to find dy dx, the easiest way is y depend on t. No need to write that. I'm just writing that for your notes. That will be negative the sine of 2 pi t times 2 pi. And the denominator will be dx dt. Again, you really don't need to write this. I'm just writing that in the beginning. And derivative of sine is the cosine of 2 pi t times 2 pi. Those undo each other, right? And I'm left with, if I evaluate this at negative 1 over 6, that would be really negative the sine of negative pi over 3 over the cosine of pi over 3, and that will be negative a negative radical 3 over 2 divided by 1/2. That's a positive radical 3. Find the equation of a line I just did. Now it says find the value of the second derivative. The second derivative of y with respect to x squared is d dx of dy dx. This y right here that we got. Where was it? That one right there. Divided by dx dt. Again, a bit messy. Provided on the exam, no need to memorize that. So that's going to be the derivative of this. Well, if I think about that, isn't that really negative sine over cosine, the tangent of 2 pi t? So derivative of tangent is negative secant squared of 2 pi t times 2 pi divided by dx dt. X is right there. And that would be the cosine of 2 pi t times 2 pi. Now, I want to point out the reason I'm not copying this, which is the same. Sometimes you reduce that, and that will change. Just be careful with that. Those under each other, evaluated at t equal negative 1 over 6. That is negative the secant squared of negative pi over 3 over the cosine of negative pi over 3. Well, cosine is an even function. It absorbs the negatives. Those won't matter. And that would be the cosine is 1/2 and the secant is 2, but you're squaring that. So that turns out to be a negative 4 times 2, 8. And that's one problem down. Next problem up is number 8. Well, if we do the same at t equals 3, if I plug 3 right there, I know the point is negative a square root of 4, which is a 2, and 3 times 3 is 9, that's a 3. So again, y minus y1 equal m into x minus x1. I would take dy dx, and I would say, well, that's going to be the derivative of y. That's 1 over the square root of 3t times radical 3 over dx dt, and that would be negative 1 over the square root of t plus 1 times 1, really? So that's going to be negative radical 3 times the square root of t plus 1 divided by the square root of 3t. If I evaluate that at t equals 3, I will get negative radical 3 times 2 over 3. So that is 2 radical 3 over 3. Negative. And there's my answer. Done with the equation of a line. If I want to find the derivative, the second derivative of y with respect to x, that would be dx of, so the derivative of the y I just found up there divided by dx dt. Yeah. d dt, correct. So that will be a derivative of this Well, if I take the derivative of that, I'll leave the negative radical 3 out of it. And that's going to be, I could do this two ways. I could treat that as one radical, right? Or I could just use the quotient rule. Derivative of the top times the bottom minus the top times derivative of the denominator all over the bottom squared over derivative, and this is the part you really want to be careful with, derivative of x. Here you simplified, so you got to be really careful not to mix things up. You need to come back to this and say derivative of that is negative 1 over the square root of t plus 1. Now on a test, this is all I owe. Evaluated at t equal 3. Well, no need to clean it up. Just figure out what that equals and everybody's happy. And that would be a negative radical 3. And let's see. If I put a 3 right there, that's a 3 over 2 minus 2 radical 3 over 3 divided by, oh, I missed over 9 divided by negative 1 over, and if I put a 3 there, that's a 2, right? So on a test, I could leave it like that. For the homework, you're going to clean that up and tell me what that equals. And that would equal, let me see, a positive. That will be 2 radical 3 times. And if I get a common denominator of 6, that will be a 9 minus 4 radical 3 all over 9. So that would be 18 radical 3 times 9 minus 4 radical 3 over 6. You could reduce that a bit. Divided by 6, that's a 3, and there it is. And the last example I want to try is number 14. At t equals 0, if I plug 0 in there, I'll get a 1 and a 0. So y equal y minus y1 y minus 0 equal m into x minus 1. And if I find dy dx, that would be the change of y with respect to t. 1 plus e to the t, evaluated at t equals 0, that would be negative 1 over 2. There's the problem done. And if I go for the second derivative, that would simply be the derivative of that, derivative of the top times the bottom, minus the top times derivative of the bottom, all over the bottom squared, all over dx dt, evaluated at t equals 0. That would be a negative 1 times 2 plus 1 over 2 all over 2. That would be negative 1, negative 2, negative 1/4. And there it is. I made a mistake. When I said over the bottom, I didn't square that. My mistake. So that makes it that'll make that 1/8 instead of 1/4. My mistake. I'm sorry. That happens.